right, so for anybody that's not aware, this is a centrifugal chiller. It's a Trane executive beige, very common to see this color scheme. That means it's typically after 1998 when they started painting them like this, I think. Prior to the UCP2 panel, which this is a UCP1, Unit Control Panel 1. You can see the mean green LED screen with the diagnostic codes and everything. Typically these were slate gray. This has been painted. You can tell some of the old paint is still underneath of there in a few spots. But today we're doing some leak repairs and we're gonna show push-pull recovery on a big machine and what it looks like. So basically you're gonna need a low pressure recovery machine because this is a low pressure refrigerant. At 48 degrees, you're in a 12-inch vacuum in the evaporator. Well, we're a little less than that. We're starting to move some refrigerant out of it. Basically, the way push-pull works is you utilize the pressure differential created by the recovery machine to push liquid out from the lowest point. So the lowest point on one of these machines that's accessible is down there. They call it the evaporator charging valve. So there's a valve and there's a, like a 16-inch nipple or something. 3/4 ID. We've got some adapters here. 3/4 MPT, a 1/2-inch flare, a 1/2-inch flare hoses running over here. So that's the push. And we're going right off of the liquid vessel, the liquid containing vessel, which is the evaporator barrel, to the liquid valve on the recovery drum. So out of that, we're gonna hook that vapor side hose up to the inlet of our recovery machine. This is a large, low pressure rated RefTech system. These things are about 10 grand. It's not mine. This is the company that I work for. Just trying to show folks how big chiller recovery takes place. So not claiming that it's mine or anything. There's our vapor in. So the theory is that the vapor in to the recovery machine is then turned into liquid somewhat, but since it's a low pressure refrigerant and it's in a vacuum, that's not what really happens. You're just kind of creating a pressure differential here like you would with any compressor. So this would be warmer vapor, and what we're doing with the warmer vapor that's at a higher pressure, it's just positive, like 3 psi, maybe 5 psi or something like that. We're running that hose over here to what they call the suction L. This is the suction elbow here for the inlet of the compressor, and we're pushing that vapor here with the recovery machine into the top. And what that does is creates force, pushes the liquid down into the bottom of that vessel, and then right back out. So it's just the refrigeration cycle, kind of sort of, if you want to relate it to that. That liquid refrigerant comes out here, runs through our hoses, and straight into that drum. And you want to use a sight glass. Yeah, you can pump a little bit in there. Use a sight glass to monitor your progress. So as you can see, we've got quite a bit of liquid moving in there. And we're gonna use industrial size A-frame to hang this drum off of. This is sometimes referred to as a pig. It's a 1,000-pound recovery cylinder. Tare weight's about 350. So as we go along, we're watching our liquid gauge, making sure that there's still liquid flowing through, and then we're watching our scale. Well, we're currently at 975, and you subtract the tare weight, which was one of these two measurements. I don't exactly remember. And as you can see, it goes pretty fast. So the liquid would go in here. This type of cylinder has a dip tube. You're gonna end up with the bottom full of liquid. As you can see, we've got sweat, we've got moisture marks up to about here. So that means our liquid level is probably somewhere around the midpoint. And depending on the pressure of the cylinder and the ambient temperature in the space here, we're gonna eventually get vapor in here. So there's probably some non-condensables in here. It's got leaks, that's why we're doing this whole thing. And then we're just pulling vapor off the top of the tank, and that goes to the recovery machine, and the process continues.